Oh, hello. Remember how sinister and how scary seeing this face in the sky was when you played the original Legend of Zelda Majora's Mask? I know how scary it was to me and how ominous it was. And it got me thinking, how big that mouth though? Sorry. But how big would Majora's Mask's moon's mouth actually be, and could it consume everything? Well, again, like I did for my Majora's Mask episode that dropped yesterday, I'm going to assume that this moon, no matter what it looks like in the game, is the size of our moon. And if you do that, you can do a back of the envelope estimation on how much surface area of this moon this mouth would take up. And I'm going to assume that it can open a little bit as well. And if you do that, you find that each bite from the moon's mouth, if it was opening, putting its full surface area on something, taking a bite, and pulling it back, would be about 550,000 square miles, which is 1/7 the surface area of the entire United States, which means in just 7 bites, the moon could indeed consume everything in the United States at least. But in one bite, it could definitely consume one town. Hello and welcome to another edition of Because Science Live, the show where I try to take all of your comments, questions, corrections, and too personal comments off the top of my head and answer them, and so you can get a little bit sense of how I think, and I want to get a sense of, how weird you guys are. So I got Nate here. Hit me.
From Papa Jake Jr., 13.
Ooh. Hey, Papa.
What would happen if 2 meteors both hit the sun at the same time? Would they just burn up, or would it just create an EMP, or would that be the end of the Earth?
If they hit the sun, would that be the end of the Earth? Okay, so you got a lot of parts of that question. I will say something. I'll say something like this. I'll start like a politician. What a handsome question. Wow. The sun is a big ball of gas. And this is not to scale, but a meteor coming into the sun, actually, I don't know if I can even draw the scale. A meteor, relatively speaking, size-wise, to the sun would be like that. Can you even see that? That. Just like that. An incredibly small percentage of mass. So the effect that a comet or asteroid or whatever would have on the sun if it impacted would be very, very, very small. But comets, but spoiler alert, but comets. But before the asteroids even got to the sun, they would start to be affected by the temperature of the sun and the radiation, the heat radiation coming off from the sun. And then they would start to be, if they were orbiting, they would start producing, if they were made of ice, or partially made of ice, they would start creating these long wispy tails as they melted away in the vacuum of space. And that's why comets look like that. So to answer your question, no, it wouldn't affect the Earth, and no, it wouldn't affect the sun. In fact, we've seen asteroid-like bodies and comets hit the sun or go near enough to the sun that they are absolutely vaporized and ripped apart by the sun's gravity. And you can actually, you can search for this. If you search for like a NASA comet GIF, you will see a comet go around the sun and then get obliterated. We've come a long way. What's next?
From Godzilla Wolf 1. In Injustice Gods Among Us, Superman punches his target into space. How much force was his target hit with?
So to punch someone into space, I've kind of gone through this in my You Don't Want Super Strength episode. But if you are punching someone upwards to give them escape velocity, which is 11 kilometers per second here on Earth, that's very, very, very fast. So you're going to have to impart a large force to their head. And if they were not a super-powered person in some way, their head would rip clean off and launch into the sky. But my point is, if you're producing an upward force on a super person, you are getting the same downward force on your fist, your arms, your shoulders. So if you were to try to punch someone into the sun, you would also be force down into the ground when that happened. But how much force would this be? I don't know. It would have to be quite a bit. Think of how much thrust we have to give a rocket just to get it out of Earth's gravity well, or to fight Earth's gravity well. Now imagine concentrating that all down into just one motion of one human-sized fist thing. It is millions and millions of pounds of force minimum. But I don't know what it would be exactly. The realistic thing that would happen would be that their head would explode. Or you go right through it. Again, you don't want to, it's gross. What's next?
From Cam Sprad. What will happen when Yellowstone erupts?
The super volcano in Yellowstone, I believe it's a caldera? But it's not like a volcano like you'd see it in the movies, right? So it doesn't look like this, like that traditional looking volcano or like Mount St. Helens or something like that. Instead, it is underneath, oh, almost copyright infringement. It is underneath the ground in a giant bubbling cauldron of lava. So, what I was getting at is that it doesn't look like a traditional volcano, and if it were to erupt because it is one of these super volcanoes, it would probably, as far as I understand, wipe out most of the life in the United States by blocking out the sun, which would lower, but with just the copious amount of ash and heat, and it would block out the sun, which would lower the surface temperature of that region. This has actually been recorded in history, large volcanoes going off and then the global temperature going down because the sun is being blocked enough for a long enough time. If the supervolcano in Yellowstone went off, it might be the worst thing that ever happened to humanity in modern times. Yeah. I mean, Krakatoa wasn't like this, but when Krakatoa went off, just the sound of it could rupture eardrums miles away. And that's not as big as that. Imagine that. The sound of Krakatoa circled the Earth more than once. Whoa. What's next?
From Douglas Page. Could you make the light daggers like the ones in Cloak and Dagger?
Light daggers. People ask me a lot about hard light, and I don't know what that would be. I also may not know what air quotes mean. How do you make something that's light that's also penetrative? That sounds to me like a laser. So if you had a handle, the handle of some kind of dagger, and then only when it was getting close to flesh did it send out rapid pulses of a high energy laser, you might be able to see that laser a little bit if there's a lot of dust in the air or something like that. And then you kind of get a laser dagger that if you, imagine this. Like seeing the light isn't the cool part to me. What's cool is using light to penetrate a target. Photons of light in high energy packets, lasers. So imagine taking a dagger and then just putting it up onto someone's body like you were stabbing them, and then the laser activates. And what this will do is the laser pulses will go in, and on each surface it will impart enough energy to the surface, let's say flesh, and it will cause a tiny little vaporization explosion, cause a little bit of a crater, and then the next pulse of the laser would go in and create a bigger crater, bigger, until it starts eating through like a knife would, like a penetration wound. That's a light dagger if you ask me. Put a laser beam into a dagger hilt. I mean, that also kind of sounds like a lightsaber to me. The problem with this is that we have not come up with a way to miniaturize high capacity batteries to the point where you could just have like a dagger with a high powered laser in it. Same thing goes with lightsabers. We don't know of a power source that could be that small, especially if the lightsaber's putting out like nuclear submarine levels of power. So you can make a light dagger like this. then credit me. What's next?
From Caroline Rosendo.
Ooh.
If Ant-Man shrunk to the size of bacteria, how fast would their movement appear to him?
What? Okay. If Ant-Man was the size of bacteria, what would bacteria look like? Well, I mean, this is kind of a cop-out, but you can look at bacteria under microscope, and you can see their little hairs, little cilia and such, moving around very, 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 very quickly. They're not slow. So it would, if you were at the scale, oh man, just imagine that. If you were at the scale of a bacterium, for example, and it was like this size in relation to my head, and it had all the little hairs that it uses as motive instruments to move through various fluids, they would be moving so fast it would look like it would look like a transparent nightmare. Also the name of my new wave band. Sure. What's next?
From Zep Master.
Ooh.
Kyle, do you really exist, or are you just a representation of the void?
Well, as you all know, I am trapped here in a formless, shapeless, emotionless void, and yes, you are correct. I am merely an amalgamation and a construct of the fear and the emptiness and the loneliness that this void represents. And so, a few times a week, I'm able to enjoy some pop culture that I remember from my previous existence and project some of the things that I find interesting about said pop culture to you. So I hope you enjoy it. But it is... It's not as cold as you expect. It's kind of hot, balmy. What's next?
From Mazenrath Ifrit.
Hey, you tried, Nate.
Is the Because Science symbol the alchemy symbol for Earth and a symbol for transmission?
Okay, so we came up with a new logo for Because Science because my old logo looked very much like my friend's logo, Veritasium. Derek Mueller is a personal friend of mine, and I realized that my logo was identical to his, so I wanted to change it. And what our logo is a representation of now, it's brand new, so let's see if I get it right. Our logo now is like this, which kind of looks like fancy pizza now that I see it. But our new logo is like this, and actually what this is in reference to is a Feynman diagram. Richard Feynman is one of the most celebrated and interesting physicists of all time. He helped make the atom bomb. He came up with symbols called Feynman diagrams that revolutionized how quantum physics and theoretical physics is taught and explored. And, you know, everyone hears about Carl Sagan, everyone hears about Bill Nye and Neil Tyson. But Richard Feynman was, if you look into his life, he really was he was legitimately a genius in the truest sense of the word, and he was an amazing science communicator. Not only in his lectures, like the Feynman lectures have gone on to be like the most useful and well-known lectures about physics in human history, and that's not my quote. That's a quote from Freeman Dyson. You know, the guy who came up with Dyson spheres and also made the nuclear bomb. Anyway, so not only were his lectures very important to science communication, like what I try to do, but the way he thought about the world, simplifying things, coming up with little tricks, like his Feynman diagrams to help explain what he saw, I thought is such a pure and interesting way to look at the world. And so I made the new Because Science logo in his honor, because I think he's legit genius and very inspiring. What's next?
From Evil Squid Studios. How much of your skeleton could you conceivably replace with metal or some organometallic compound without too greatly affecting your ability to produce blood cells? Asking for a friend.
Is your friend Wolverine? The problem that you're getting at, let's see if I can. So the problem that you're getting at is that if, oh wow, what a misshapen bone. Your blood cells are made inside of your bones. And I think what you're getting at is that if you cover your bones in some kind of metal, then your blood cells can't get out and you would die. How much of that process could you interfere with without dying? I have no idea. I know that this is not the same question, but I know that you can't even lose very much of your blood before you are seriously impaired. They don't take that much blood out of you when you give blood, and anything more than that, some people faint, you get woozy, you get very incapacitated very quickly. I do not know how many bones you could cover in adamantium before you got dead. Nope. What's next?
From DJ Phoenix.
I tried.
Could it be possible to shrink a building or enlarge an inanimate item quickly, as shown in the trailer for Ant-Man and the Wasp?
So, insider information. I know the quantum theoretical physicist who advises on the Ant-Man films, and I asked him, hey, what's up with all those mass problems? The mass problem is that if you took something, if you take, what's in the trailer? If you take a salt shaker and you shake it like a salt, shake it like a salt, whatever, and you, shut up, and you increase its size without changing its mass, the volume goes up. And because density is mass per volume, this becomes less dense. And if you scaled this up enough, it would be dense enough to float away. Yeah, and the opposite is if you take a building, all the mass that is a building, and you shrunk it down to something that could fit in your hand, it would be dense enough to sink into the earth. So I asked my friend, does the mass stay the same? Does the mass change? And he said, I have thoughts on it, but it's not in the film. So this question will go unanswered. That's just how it is. So sometimes people ask me about science consulting for Hollywood films. I live in Hollywood, and I don't do it because they usually go for people, who are working scientists, who have PhDs, who are professors, because, there's just name recognition and there's credits to their name and they're smarter than me. So it's fine. People like me usually don't do consulting. But what I know from interacting with doctors and professors and stuff, and some of them I know, there's a fundamental tension between how much science do you want to put in your film? How much do you want to get right? And there's always back and forth because the scientists say, well, this and this and this and this and this have to change, and the director says, how about just that? And so there is a legitimate balance to be made between narrative and accuracy. And I think that's perfectly valid. Don't let your accuracy and your science get in the way of the story that you're trying to tell, unless it's a story about science and scientific accuracy. Sometimes science has to take a back seat depending on what you want to do and what you want to show, if that's what you're doing. Or you could make it part of your narrative, like The Expanse. Hashtag put me on it. What's next?
From White Nico Knight.
So shameless.
Is there a definitive increase in the chances of finding life outside of our planet, Mars, increases when organic compounds are found on that planet?
Okay, so I think what you're referring to is there was a new NASA study, I believe, that detected organic molecules on Mars. What does that mean for alien life? It means nothing other than stuff that could be used by or could go into life is there. It doesn't mean it was produced by life, and it doesn't mean it's going to make life. So when you're looking for exobiology, biology beyond our Earth, you would look for telltale signs. One would be oxygen in the atmosphere of a planet, because oxygen on our planet was created by life. That's something you could look for. You could look for methane or something like that from biological processes, and that's a clue, but it's not proof. It increases the chances, I guess, that life could be there as opposed to like a sterile environment with no atmosphere, but it doesn't mean life is there or was there. It's just the ingredients. It's like, yes, having all the ingredients for a soup makes the ability for that soup to exist more likely, but it doesn't mean that you have a soup. I think that metaphor works. What's next?
From JSB.
Life's just a soup. Life's just a bowl of clam chowder waiting to be stirred. quote me on it. I'm sorry, what was that?
From JSB,
JSB.
are there any modern video games that get science somewhat correct?
There's a so the kind of video games that I like to play are more narrative RPGs. I don't. People ask me, like, do you always have to, watch or enjoy things that are super accurate or super sciencey? No, I mean I'm fine with, again, like I said, having narrative take precedence over accuracy if that's what they're trying to do. That's fine. So the video games I usually play are narrative RPGs that I can lose myself in the experience of that for a while, like God of War 4, which is fantastic, like The Witcher 3, very unsciency games, but I enjoy them quite a bit. What I have started to get into, and I'm looking to get more into, are games that aren't these big AAA titles, but are incredibly sciencey and incredibly fun. Universe Sandbox 2 on Steam is a simulator that will let you crash the moon into Earth at light speed to see what would happen, scientifically accurately speaking, which is awesome. You can change the orbits of the planets, you can do all these wonderful things. Another game that's highly recommended to me by people like Matterbeam and some of the other commenters is a game also on Steam called Children of a Dead Earth, and it's supposed to be a completely scientifically accurate space exploration, navigation, and it's that kind of game. So you can build your own spaceships, and they have to be accurate as you fight other spaceships. The battles are accurate. You can come up with your own orbital trajectories to get to your location and stuff. And it's all very sciencey. I've been looking to get more into that stuff. But usually after I'm done, after the void is done with me, I'm very tired and I kind of just chill with cats. What's next?
From DS, what is the largest a planet can get?
I don't know. I mean, planets can get larger than Earth, for sure. That's why when you hear reports of super Earths with a few times the mass of the Earth, and they exist, and 3 times the mass of the Earth, they can be larger than Earth. But I don't know what the limit is off the top of my head. I would have to ask an astronomer, or you could just, pop a goog on the old internet machine. But I don't know what the limit is. I imagine that there is a density at which, because gravity will compact the mass together, there is some limit before it would destroy itself or become a gas giant or something else. But I don't know. Good question. What's next?
From Sean Hale, how quickly can you think, Kyle?
Dude, really pretty fast. What's next?
From J.M. Pickering, aside from super strength or super speed, what is your top superpower you would want? Or you wouldn't want, excuse me.
Well, yeah, it sounds like you're asking me for what the next episode in that little semi-series that I'm doing is. The other ones I want to get to for You Don't Want X for reasons ABC is flight, X-ray vision, and invisibility. Those will probably be coming down, coming through the pipeline pretty soon. I like doing those kinds of videos because they're not overtly debunky, saying like you can't have it. More so, if you apply science to it, you might want to think harder about your choices. I like that. So expect more of those. Flight, invisibility, and X-ray vision, probably soon. What's next?
From BSparks112.
Hey.
If dragons were real, could they actually fly? Or would that be too heavy to achieve lift?
Yes. But, yeah, dragons are big. At least in, like, Game of Thrones, Drogon looks to be the size of a Tyrannosaurus Rex, and Tyrannosaurus Rex could be I know this off the top of my head for no reason in particular. T-Rex could be about 8,500 kilograms, 13 meters long, over 40 feet long. They're absolutely enormous animals. And to get that amount of mass off of the ground, I don't know the calculations off the top of my head, and their biology would have to change. Their bones and skin would have to get stronger. But the wingspan of probably almost every dragon you've ever seen in anything is too small. If you're hauling a lot of mass into the air, those wings get much, much, much larger as the mass goes up. I think one of the largest animals to ever fly is let's see. So one of the largest animals to ever fly is a pterosaur. One of the first animals to fly in general, aside from insects, and their wings were something like this big compared to the human, and they're only about that tall. Like that's where their shoulder would be. And they were very light. They weren't that big. So a Tyrannosaurus Rex-sized dragon like Drogon would have to have wings that would black out the sky. So could they fly? Yes, if their wings were much bigger and the associated biology was also strong enough to handle the immense forces, the immense downthrust that these dragons would have to create. Their muscles would have to be huge, which would make them heavier, which would make the wings heavier, which would provide a limit on. It gets complicated, but dragons would have to be bigger if they could fly. Is that it?
Short question.
Short question. Last question.
Kyle Larkins. In Star Trek Into Darkness, Kirk and Khan are ejected into space from an airlock. Would the force of that sudden motion just have killed them both?
Were they? When? Is that the one with Cumby B? Oh, when they shoot themselves out as torpedoes? Oh, would that have killed them? It depends on how fast they were going. Well, it doesn't depend on their absolute velocity. It depends on how quickly they got to that velocity, i.e. it depends on their acceleration from 0 to whatever that final velocity was. You will feel uncomfortable in a car that accelerates anything more than 1G. A Tesla Roadster will do that. It'll do like almost 2G, and it'll feel close to 2G, and it will feel very unnatural. Once you start getting beyond this, you start getting into like fighter pilots, and then you start getting in roller coasters. You start getting into the highest G's I think someone's ever pulled, eyeballs in or out. It's like 45G. So it depends on how quickly they accelerate it. I do not think it's 45G, because then they'd be going near the speed of sound outside of that airlock. I don't think they were going that fast. I think there's probably a range that they were fine. And with that, thank you for watching another episode of Because Science Live. Leave me your comments, questions, corrections, and weird thoughts on all of the locations that we have for this channel on youtube.com/becausescience. It's live. YouTube.com/becausescience, Facebook.com/becausescience, and @becausescience on Instagram and Twitter. And if you're on YouTube, hit that notification bell, because we do things like this. The live streams every Friday. We have the new episodes every Thursday, and we have the vlog referring back to that stuff and taking more of your comments and questions every Tuesday. So, check back in next week. Thank you. Oh, and be nice to each other. Especially, you can see how hard it is to be. Sometimes you can see how hard it is to be fulfilled and be happy. So take every opportunity to be nice to each other and be nice to yourself. You deserve it.